Right, so we have this little triangle here, okay? We know that sine of x is 3 over 5. That's my ratio, okay? So sine x, it's a function of x, and the answer is 3 over 5. But what about this down here? Sine to the minus 1 of 3x, or inverse sine, or that's actually called arc sine, okay? This arc sine 3 over 5 is how we get the angle, okay? So you can consider this an angle, okay? Because that is x and x is our angle, okay? So your inverse trigonometric function gets you an angle, so it is an angle, all right? Sine x equals 3 over 5, or sine of 30, sine of 40, they're ratios, okay? Sine of 40 would get you a fraction. Sine of 45 gets you a ratio, okay? So this bit is your ratio, and this bit is your angle, okay? So we're just going to use that information now to answer a few questions, okay? Okay, write down the value of each of the following angles in the range 0 to 90. So sine minus 1 of a half. Really, what that's saying in words is the angle whose sine is a half. Now, I can either go to my log tables and I'm looking for the angle whose sine is a half. So if I go sine and my answer is a half, the angle is 30 degrees. Or I can just do shift sine a half into my calculator. Okay, so the answer there, 30 degrees. They just want you to understand what is an inverse trigonometric function. It's an angle. Okay, part 2. So I'm looking for the angle whose cos is 0.8. Now, I'm only going to be able to get that using my calculator. So, shift cos 0.8 equals 36.86. So 36.9. So now that we can see that an inverse trigonometric function is an angle, we can use that now for a few more questions. Okay, can I get rid of the board? So, example 2. This might look horrible, but actually when you get down to it, it's not that bad. Okay, so this is saying express cos of this angle in terms of x. Okay, so this is an angle. Now, sine to the minus 1 of x means you could call that that is an angle, okay? So that's this down here, sine to the minus 1 of x, okay? That's the angle. So that means that's an angle whose sine is x. So an angle whose, is it whose? Yeah, whose sine is x. So sine of the angle is x. We know sine is a ratio, needs to be a fraction, opposite over hypotenuse, so it's x over 1. Okay, so opposite is x, hypotenuse is 1. Now, I'm interested in cos of this angle. For cos of the angle, I need the adjacent. Okay, how am I going to get the adjacent using this triangle here? Lovely, thank you. So, this thing squared, okay, we can call it y if you want for the minute. 1 squared equals y squared plus x squared. So y squared is 1 minus x squared. So y is the square root of that. So if I'm interested in cos of that angle, it's adjacent over hypotenuse. So cos of my angle is adjacent, which is this thing, over hypotenuse. So it's just square root of 1 minus x squared. Okay, they want it in terms of x. That means you can only have x's and numbers in the answer. Well, I do only have x's and numbers. Okay, let me just do another part to that. Are there any questions there?
What was the point of getting the x over 1 if you...
The x, this part here?
Yeah.
That's just showing me, like, if it wasn't over 1, you know, if they told me sine to the minus 1 of 3 over 4, well, no, 2 over 5. Basically, I have to put it equal to 2 over 5 so I can see that it's opposite over hypotenuse. That's the only reason I write this, just to be able to draw my triangle.
Okay, thanks.
Okay, part 2, so...
You have to put the cos of sine over the 1.
No. So like that was just me saying adjacent over hypotenuse. Really, that's your answer there.
Oh.
Okay, but I just did it because it was adjacent over hypotenuse. Like if that 1 was a different number, yes, you would need it. Okay. So part 2 of that. Evaluate sine of 2 times this angle. Okay? We've a double angle. We've sine of 2a, for example. Okay? So you might decide you're going to let a, because it's an angle, equal to this. And I know that's an angle. Okay? So a is the angle whose tan is 4 over 3. Okay, let's write that in words just to help you. A is the angle whose tan is 4 over 3. Okay, so if we're going to draw, this is my angle A, or you could write that they're both interchangeable. Okay, You know that's an angle. I know A is an angle, okay? So tan, I know tan of A is 4 over 3. So opposite over adjacent, 4 over 3. Now this is a triple that I know works with Pythagoras. Do you know what the hypotenuse is? Well, I'm not drawing it again, sorry. We'll just call that x, okay? 3, 4 and 5 are a Pythagorean triple, but to find it, hypotenuse squared is the other side squared plus the other side squared. So 9 plus 16. So x is the square root of 25, which is 5. Okay, so 3, 4 and 5 always work. So I know that's a 5 up there. Now, my question is sine of 2 times my angle. So I'm interested in sine of 2a. Okay, 2 times my angle. I let that be a, so that's sine of 2a. Now, if I go to my log tables, I can find what sine of 2a is. Sine of 2a is 2 sine a cos a. 2 sine a cos a. So basically, if I want to get what sine of 2a is, I'm going to need to find out what sine of a is from my triangle and cos of a from my triangle. Okay? So sine of 2a is 2 times sine of a. Now sine of a is just sine of this angle. Opposite over hypotenuse. So that's 4 over 5. By cos of a, adjacent over hypotenuse, 3 over 5. Now, I'm just going back to the question because this is what they asked me to evaluate. I know that's 2a. And multiply the top by the top, the bottom by the bottom. And I get 2 by 12 is 24 over 25. So that's that evaluated. Okay.